Okay, we're going to answer the question, is the line tangent to a circle? Okay, so here we're not finding any lengths, but basically, if a line is tangent, then it is perpendicular to the radius, right? That was part of our other theorem. Yes?
Yeah.
So the only thing I need to be able to do is check to see, are these two, is this a right angle? That's my question. How do I check in a triangle to verify if I have a right angle or not? I'll give you a hint. We just used it up there. Pythagorean theorem. If a triangle is a right triangle, then it should work in the Pythagorean theorem, right? You just have to make sure you get these in the right spot. Which of these numbers should be by itself in the Pythagorean theorem?
25.
25. It is the largest, yes?
Yes.
And these should be perpendicular, so they should be legs. So you're going to use the Pythagorean theorem to test. All right, so basically you're going to plug in and say 7 squared plus 24 squared should equal 25 squared if it's a right triangle. So that would be 49 plus 576 equals 625. And it does add up to 625. So the answer would be yes. You know, on a quiz or a test, that simply saying yes or no would not be enough. Okay? You'd have to show the work to verify that it is a right triangle. You don't get any lucky guesses. Okay. And one more concept. Okay. These are circles inscribed in polygons. Now, before we do the circle inscribed in a polygon, we have one theorem that is pretty handy. All right. If two tangents intersect outside a circle, then the segments from tangent from the point of tangency, here we go, to the radius, or to the intersection, are congruent. Basically, a fancy way to say, from here to there, those two segments should be congruent. Okay, we can't say the tangents are congruent because tangents are lines, and we don't talk about lines in terms of congruence. They go on forever, so you can't really compare that. Okay, but the way this works, and it always stinks to try and draw these, do a circle. I don't know. I've tried it both ways. I've tried to draw the triangle first and then make the circle fit, and I've tried to do the circle and make the triangle fit, and just do your best. Okay, so we have all these points, and what they would be telling you to do is find the perimeter of triangle ABC. When we know this, and this, and that. Okay. So, yes. No, because if the segments are longer, you know what I mean?
Oh.
Yeah, some can be longer if you put them at different angles. Some are longer, some are shorter, yeah. So, but what we do get is using this theorem, I would go around and mark what is congruent, okay? These are not congruent, but those should be. These two should be. Notice I'm not using the same number of marks. I don't want to say they're congruent to these, okay? And those should be. Okay, perimeter is just adding up your lengths, but until we have all of them, you don't want to start adding. So if this is 15, then that's 15. This one that we don't have should be 8. And this one that we didn't have should be 10. And one thing that's kind of nice about these is you have pairs of everything on one like this. So you can write them down in terms of your pairs. So instead of 10 and 10 and 50, you know, you can say, okay, I've got 20 and 30 and 16 for my perimeter. Less to right, yes? So that'd be 50 plus 16, or 66. We'll just say these are inches. Okay, and we are going to do one of your homework problems. All right. So number 12. Biggest mistake that someone makes on one like this is they go, oh, well, if this is 1.9, then that should be 2. No, those aren't congruent. They're not congruent on either side of the tangent, the point of tangency. The pairs, like on your little clown hats, those are congruent. So what you have to do for this, because we need this one, but we don't know what that is, you have to start with the little segment that you know and go that way. So start labeling. If this is 1.9, then that's 1.9. And if this is 1.9, but the whole thing is 3.4, then the rest should be the difference, right? So the rest of it should be 1.5. And if that's 1.5, then that is, and this will be the difference between 3.6 and 1.5, which is 2.1. And if this is 2.1, so is that. And if that's 2.1 and the whole thing is 3.7, then this would be 1.6, which gives us the one little piece that we were missing, which is 1.6. Okay. Now, on something like this, I wouldn't use the pairs to add it up. You have full lengths, except for that side. So your perimeter, I would do 3.4 plus 3.6 plus 3.7. And then if you either want to add those separately or combine them, okay, 1.9 and 1.6 would be 3.5. Okay, so your total perimeter would be 14.2. We'll just say these are inches also. Okay. So homework.